We're here at the Splash conference in Amsterdam, and I'm very happy to introduce to you Andy Ko, who is a professor of information science and computer science at the University of Washington in the US. So thank you for doing this interview, Andy.
Sure.
So my first question is about your keynote at Splash, where you expose a vision of programming languages with a human view on programming languages. Can you briefly tell me what it is about and why it matters?
Yeah, sure. So the human view is in contrast to really the computer science view of things. I think in the history of computer science, most research is really focused on the technical aspects of what programming languages are and how we build them, how we make programs more efficient by making better programming languages. And what I really wanted to do for this audience was try to focus on the experience of using programming languages that every software engineer is intimately familiar with. So some of those experiences include struggling to express what you want with a language. Sometimes the experience is more about a sense of control or power over shaping what technology is and shaping people's experiences. So it's all of those other things that are the human experiences of interacting with programming languages that I want to surface for this audience to try to help them think about both sides of that equation instead of just one.
So if you look at your research work, then it basically is at the crossroads or the cross-section of different fields: software engineering, programming languages, human-computer interaction. Is this sort of an historical artifact of your career, or is it something that you actively seek to solve certain problems?
It's a great question. It's actually something I talk about in the keynote a little bit too. I think it's a historical artifact of, in some ways, the friends that I had when I was a child. I was really interested in technology. Almost none of my friends were. They were all artists, they were all musicians, they were interested in other things. And so part of my experience growing up was actually seeing computing as something that other people used to express themselves or to create things, not as something that was sort of an intrinsically interesting artifact like I tended to think of it. And so as I moved through school and I got to college, it was really natural for me to be both interested in computer science and human behavior. So I was a computer science major and a psychology major at the same time. So that took me on to graduate school where I thought about both of those sort of equally and was really interested in that intersection. As I developed as a researcher and became more productive and prolific as a writer and an investigator, I realized that there was actually quite a bit of opportunity to do research at that intersection as well, because most people are either a psychologist or either a computer scientist, but not something that really combines both of those perspectives. And that's really sort of the unique contribution I found I could make to research.
Okay, so and apart from this interdisciplinary approach, you've also been involved in a startup. So has this had any influence on the problems that you investigate or the way you do research?
Yeah, there's been I don't even know if I could name all of the ways that it's impacted both my research and my teaching, but I can name a couple of really significant things that I found. One of the consequences of working at that intersection of human behavior and computing is that many of the problems I chose before I did research, before I started the company, were very applied problems. I wanted to solve problems that I thought were relevant to people. And so that meant that I chose things that really had direct applications where I felt I could change the way that somebody's experience with a programming language or a development environment was. When I went into industry, what I found was that although those were problems the developers had, I managed a team of 8 to 12 developers at any given time, they had those challenges. There were deeper challenges that they had. And many of them are actually about much more basic questions in software engineering and programming languages, and not really the applied ones. In fact, programming languages themselves were not even that important to most developers. Most of my developers struggled with things like, how can I be a better software engineer? Which meant I needed to answer a research question like, what is a good software engineer? I actually had a PhD student who worked on that for about 5 years and just finished his dissertation. And we found all of these fascinating things that make an engineer great or not so great, and all of these really interesting questions about how do we know that somebody has those skills. In job interviews, for example, we don't even know how to detect whether somebody is a good communicator, for example, because we don't know how to define good communication in a software engineering context. So many of my questions became much, much more basic and much less applied, which was a very surprising thing to me.
Right. So back to programming languages. So one of the workshops at this conference is the Plateau workshop, which tries to do research into the usability of programming languages. So would it be fair to say that a programming language is just a user interface, or is it still some unique in some way?
Yeah, it's a really interesting question because programming language as a user interface is sort of the first idea that I had of what a programming language was when I first learned to code. I never thought of it really as a sort of formal mathematical logical thing. That was something that came much later. And that was reinforced by a lot of my training too when I was in graduate school as a PhD student. My advisor, Brad Myers, his whole background was in user interface technology. It was about expressing computation in a way that was usable and accessible to people. And so when I talked about languages with him, every conversation we had framed a programming language as an interface. And that meant certain things. It meant we thought about what are barriers to expressing what you want. When you do express something and the computer doesn't do what you expected, good user interfaces help you understand why that happened and help you correct for that, right? Good user interfaces prevent errors. Programming languages should too. So all of those ideas from user interface design are actually highly relevant to programming languages. It's just that in research we don't usually think of them as interfaces, so we don't ask those questions.
So there's been this recent research effort to sort of move away from programming languages as a concept and talk more or discuss more about programmer experience. Do you think this is aligned with this usability and programming language as a user interface vision, or do you have a specific take on this?
Yeah, the experience question is interesting. I think that when I think about the engineers that I managed in my company, they were certainly constantly complaining about their tools and about their programming languages and frustrated about things that didn't work well. And in some ways, experience and good programming language design are kind of the same thing. If you design a good language, the experience should probably be good too. I think the difference is that in research, we often just don't look at experience. And so we often don't know if our design is good, right? So we design languages and we think that they're good and we make claims about them being good, but we never observe to see whether they're good. And because that loop hasn't been closed, it's really hard to improve languages and design better ones.
So final question. Based on your research and experience, what do you think will be the next big thing in programming systems or programming languages?
Yeah, one of the things is something I think is already happening, and that is that most people who are really experienced software developers and most researchers who look at programming languages don't realize just how many people in the world are actually programming and using all kinds of languages to do it. So the idea, for example, that there are about 50 million people in the world that write a lot of functions in spreadsheets and write very sophisticated programs on that platform. And programming language researchers and software engineers don't think a lot about the programs that those people are writing. Turns out that most of those spreadsheets have a lot of defects. Most of them need a lot of testing, most of them need a lot of verification, and we haven't thought a lot about how to actually do that for that platform. So then you take spreadsheets and you think about all of the other domains where people are programming. For example, a lot of the news right now are around manufacturing around the globe being automated instead of being driven by human labor. That's because robots are doing it. And the people who have to program those robots are actually just skilled, trained people who are good at scripting CNC machines and other types of things. So what is good testing? What is a good language? What are good practices for software engineering in those domains? These are wide open questions. And I think that a lot of the opportunities for trying to improve programming languages are going to be really in other domains we don't usually think about.
Thank you very much for this interview. So this concludes the interview with Andy Ko here at SplashCon in Amsterdam.